Hey everybody. We're gonna start talking about that topic called density. In order to do this, we're gonna break it down into a series because it is a tough topic. I'll admit, this is a topic that many kids do struggle with. So we're gonna break it down and go through it bit by bit. The topic of density we will build up into. I just want to tell you right now that density involves two topics you've talked about in the past. Density is going to involve mass and then something known as volume. Okay, so we're going to actually calculate density by finding mass and finding volume, but we have to break it down first. So we're going to start simple. We're going to start with mass and what mass is. Many kids in the past have mixed up mass with the word weight. Mass is not weight. Weight has to do with gravity, and gravity pulling us down to earth. We're standing on the ground, and that corresponds to how much you weigh, okay? Mass really has nothing to do with that. It's how much matter is within an object, okay? Your weight can change. Your mass will not change. So I'm going to play this video. It's real short. It's like 1 minute and 30 seconds. I want to tell you that there's certain parts of it that have a little bit of extra information. So if your mind's kind of spinning, don't let it, because you only need to know the basics. So here we go.
Mass and weight measure the same thing. Close, but not really. The mass of an object is a measure of the number of atoms in it. The SI unit for mass is the kilogram. Weight is a measure of the force that gravity is pulling on the same object. Gravity is a force and technically should be measured in newtons. A newton, represented with capital N, is equal to the acceleration of 1 kilogram, 1 meter per second. Your weight can change based on the gravitational pull of your location. For example, you weigh less on the moon than on Earth. The weight of a candy bar that has a mass of 101 grams exerts a force of 1 newton when held in your hand. When you step on a scale, it is an accurate measure of your mass, but an estimate of the force of your weight that is exerting on the scale. To find out how much force a 100-kilogram dog exerts on the, just multiply by 9.
Okay, so that's enough for that video. What I mainly wanted you to get out of that video was really when they talked about mass will not change and your weight will, because, for example, I'm composed of so much matter. If I were to travel to the moon, my weight is going to change. Why? Because gravity changes on the moon compared to Earth. So my weight will change. However, how much matter makes me up is not going to change. Therefore, my mass remains the same. Okay? I'm going to pause the video real quick, and now that you know what mass is, now we're going to go and calculate it, okay? Okay, I pulled up a worksheet that we have done in the past, and we can't do this in person because can't really share paper currently. However, we're going to try to do this as best as we can virtually. What I want to go over with you is that typically in a lab setting, you would have a triple beam balance, and you would have all the riders over at 0, like these little block things would be at 0, okay? Then you'd put the object on the plate part of the triple beam balance, and you would typically you start with like the, I want to say that a lot of people start with this top one, and then we'll move this over. And essentially, you want the balance to balance almost like a seesaw, where both sides are kind of just equal, standing up in the air, and one side's not clunked to the ground, okay? So that's how you would use it in a lab setting. You could go to many YouTube videos and search it and see how you use it, but it's pretty easy. And a lot of the times in today's day and age, we just use digital triple beam balances, but you need to know how to read the old school balances, and these are the old school balances. So in order to read this, what you're gonna do, you're going to add. We're only adding here. So mass is going to be addition, all right? What we are going to do is just add up all the riders. So on here, you're probably seeing that it's 90, 100, and then you're going to read this last one. Many kids in the past have read this one kind of wrong. You're almost reading it like a number line or a ruler. So you see like the rider, the point has not passed 1. So it's not going to be 1, it's not going to be 1 point something, no. Right here, it's going to be, you see this is at 0, so this should be 0.1, 0.2, 0.3. It's like, it's hard to see, but we know this is 0.5, so this is like 0.4. So this would be like 0.4. So you can do the math off to the side here and add everything together. Or you can go ahead and use a calculator and you can type in 90 plus 100 plus 0.4 equals 190.4. And you'd write 190.4, oh, my pencil's there, yeah. And my handwriting is not very good because it's on a trackpad, and if we had iPads, it would look a little bit more pretty, but yeah, we'll just have to deal with that. But anyways, wait, this is right. That's the number. But in science, numbers only mean so much. You have to put a unit of measurement behind your number. So what you're gonna do for mass, we in 6th grade always use grams, and we use the abbreviation of just a G. So mass, we typically will do addition, and then the unit of measurement is in grams, okay? All right, so I'm not very good with like the eraser thing on this. Wipe screen clear. Okay, perfect. So that's that. So, okay, cool. So now I can hopefully, if I exit out and then I can move down. Perfect. Okay. So now let's go to the next one. We're just reading and tallying up the riders here. So I'm going to use a different color. Let's go ahead and use green. If you see, this is 30. This is 0. And then you can see that it's at 7, but it's a little bit past the 7. So it's going to be 7 point something. So you see this is 7, 7.1, 7.2, about 7.3. Okay? So I'm just going to kind of write in there 7.3 to help me remember. And we're going to add all that up. So you could add it up off to the side and do your thing. Or you can pull up a calculator because we can use that in science. And you're going to do 30 plus 0 plus 7.3 equals 37.3. So on here, you write 37.3. And remember, we always have a G behind grams. That's how you know it's mass, okay? So that's that one. Before I move any further, I'm going to wipe the screen clear, and what I want to show you guys what to do, I forgot in this video to actually show you how to get your calculator if you don't have it. So many of you won't have it at the bottom here. What you're going to do is click on the Launchpad. If you notice all these apps pop up, you can type it in here and search calculator if you don't see it, and it's right here. What you're going to do is click, drag down, drag it to the bottom, hold it there, let go, and it should be on your desktop then, okay? if you scroll down, we're going to do one more because mass is kind of easy. It's just getting in that repetition and that habit, okay? So for mass, here again, let's use a new color. We'll use blue, blue-green, whatever you want to call it. So we see this rider's at 0. This rider is at 100. And then this one, we know it's going to be past the 5. So it's 5.1, 5.2, 5.3, 5.4, 5.5, and then 5.6. Okay? So right here, I'll just write 5.6 to help me remember. And again, you can do the math off to the side if you want to, or you can pull up the calculator and you can type all that in. So it's 0 plus 100 plus 5.6. And you can see that the answer here is 105.6 grams. Okay? Remember, we always have G after the number because we need a unit of measurement, and for mass, it's going to be grams. I do hope that makes sense, and remember to reach out if you need anything, but mass is pretty easy. Your next video will be on volume, okay?